The third type of if statement in Python is the if-elif. Let me demonstrate the general syntax for that if statement. So we have if followed by a relational expression. Inside that would be the statements. And then you'll say elif and another relational expression followed by a set of statements, one or more. And we can continue with elifs as long as we need to. I'm going to stop after this one. And then finally, you can have an optional else. The else will execute its statements if, and we left off a colon right there, if all of the other relational expressions are false. So an example of when you might need a if-elif is with the grading scale, when you're taking numeric scores and assigning values. So for example, greater than 89 is a letter grade A, using the 90 to 100 scale. 80 to 89 is a B, 70 to 79 is a C, 60 to 69 is a D, and anything below 60, so less than or equal to 59, is an F. So if you're looking at a numeric score, you might say if grade is greater than 89, letter grade equals A. Elif grade is greater than 79 or greater than or equal to 80, letter grade equals B. Elif grade is greater than or equal to 70, letter grade equals C, and so on. In fact, let's look in Python how to actually write that simple little program to demonstrate how the if-elif works. So let's move to Python. We'll call this if-elif.py. So the first thing we're going to do is say print, enter a numeric grade, and then we'll say grade is equal to int raw input. And then we'll say if grade is greater than or equal to 90, letter grade equals A, elif, and actually I'm going to take the parentheses off this. If you come from another programming language into Python, you'll be like me and want to always put parentheses around your relational expressions. That's not a common idiom in Python, so trying to follow the convention of most Python programmers, I'll take my parentheses off, although it's hard for me to do. Then we can say elif grade greater than or equal to 80, letter grade equals B, elif grade greater than or equal to 70, letter grade equals C, elif grade greater than or equal to 60, letter grade equals D, elif grade less than or equal to 59, letter grade equal F, else print did not recognize input. We'll add this else part for if the user enters something that's not in that range or enters some input that's not a number, for example. So we'll have a print statement and print and say your letter grade is letter grade. Okay, so let's exit and save. And try it, if-elif.py. I haven't made too many errors. This one's just a typographical error. I do like to leave them in because you'll see how I solve these problems. This is an easy one to fix. I just forgot to put the colon right here. So let's add that in real quick. Exit and save again. Chock full of mistakes today. Same thing right there. One more time. That's the end of the program, so there shouldn't be too many other errors. So let's just try a middle grade 77. Your letter grade is C. Let's run it again. Let's try a high score. That's good. Let's run it again. Let's try. Now let's try, for one more attempt, let's try something that's outside the range. Let's try a letter. In that case, it failed in our input, which is fine. Just trying to show you what would happen if the user entered something that was not a legitimate number. Later in the course, we'll talk more about how to handle errors like this, but I just wanted to demonstrate what would happen if the user entered something outside the range of numbers. For this first exercise of the chapter, we're going to write a program to play a simple little guessing game. So let me make sure I don't have my previous version up here. Okay, so it's gone. So we're going to call our program guess.py. So let's open it up. So the first thing we're going to do is store the answer to the game in a variable answer. And the answer is Watson. And in a moment, you'll find out what the question is. First, we're going to tell the user that we're going to play a guessing game and they get 3 tries. And we're going to say, what is the name of the computer that played on Jeopardy? So the first thing we do is get the user's response. We'll store it in a variable called response using raw input. Now here's where we test. We say if response equals answer, print that is right. Else, print sorry, guess again. And then we say response equals raw input, and then we test again. So here we're nesting an if statement inside the else, or actually in the if. These are called nested if statements. If response is equal to answer, then we tell the user that they're right. Otherwise, else, print, sorry, one more guess. And again, response equals raw input. And then if the response is equal to the answer, print that is right. Else, print sorry, no more guesses. The answer is, and we'll just use the variable value answer plus a period. Let's test this and see how well it works. So we'll do an exit save, clear the screen, and then run the script. And let's say deep blue. It's not deep blue. Okay, it's Bob. Oh, that's right, it's Watson. And so on the 3rd try, I got it right. Play it again. This time we'll get it on the 1st try. Let's play it again. We'll say ENIAC. Then we'll say Watson. One more time, and this time let's not get it right at all. ENIAC, sorry. Deep blue. Joe. Sorry, no more guesses. The answer is Watson. So here we've used the if statement, the if-else statement, in a nested manner to allow the user 3 guesses. A better way to write this program would have been to use a loop that looped through 3 times. But we haven't learned how to write loops yet. We're going to learn how to do that in the next chapter. So this was the best way I could think of to write this program and demonstrate how to use nested if-else statements. With that, we're finished with this exercise, and we're ready to move on to the next and last exercise of this chapter, where we demonstrate how to work with the if-elif statement. For this last exercise of Chapter 6, we're going to demonstrate again how to use the if-elif. This time we're going to write a little program that suggests activities at a resort based on the temperature. So if you're sitting in your room with a computer, you could type in the temperature, and then the program would give you some suggestions of things to do. So let's get started on that. We're going to call it activity.py. First thing I'm going to do is write a stock message that will fill in based on what the user enters for the temperature. So we'll prompt the user to enter the temperature now, and then we'll get that using the int conversion function and raw input. And now we begin the if-elif. So we say if temp is greater than 85, message is equal to message plus swimming. Elif the temp is greater than or equal to 70, and then we suggest that tennis is the right activity. Elif the temp is greater than or equal to 32, the recommended activity is golf, although 32 may be a little bit cold for golf. We'll leave it there. Elif the temp is greater than or equal to 0, then the recommended activity is dancing. And then otherwise, else, the recommended activity will be sitting by the fire. And then we'll just simply print the message. And we're finished. Scanning the code, I see I left off a colon right here, so let's add that in. And I left one off right here also. Now I believe we're ready. So we'll exit and save. And then run the program. So let's say the temperature is 56. The recommended activity is golf. Let's run it again. Let's say it's 99. Then the recommended activity is swimming. Let's say it's 72. Then we have tennis. Let's say it's 23. Then dancing. And then we're in the far northern climes and the temperature is -10. The recommended activity is sitting by the fire. So there's another example of how to use the if-elif to make decisions based on a series of related possibilities based on the input data that the program receives. And with this, we're ready to end this chapter on decision making, and we're ready to move on to the next chapter where we're going to talk about writing loops. In this case, we're going to talk about the while loop, which is the first of the types of loops we're going to talk about.